nitro compound. Cn means cyanide, we know very well. In IUPAC, what is the suffix here means nitrite. Then NC, what is NC means? It is isocyanide, and in IUPAC the suffix what we are going to add means carbylamine. And one of the hydrogen replaced in methane, and then infinite of hydrogen NC added means that name of that compound is methyl isocyanate in common name, and IUPAC name we will see in the PPT. The next one, in benzene, one of the hydrogen is replaced with NC means the common name is we called as phenyl isocyanate, and IUPAC name also we are going to see in PPT. In this video, we are going to see the preparation and chemical properties of isocyanate. Rest of the lesson in PPT. Friends, nitro compound, Cn means cyanide, we know very well. In IUPAC, what is the suffix here means nitrite. Then NC, what is NC means? It is isocyanide, and in IUPAC the suffix what we are going to add means carbylamine. And one of the hydrogen replaced in methane, and then infinite of hydrogen NC added means that name of that compound is methyl isocyanate in common name, and IUPAC name we will see in the PPT. The next one, in benzene, one of the hydrogen is replaced with NC means the common name is we called as phenyl isocyanate, and IUPAC name also we are going to see in PPT. In this video, we are going to see the preparation and chemical properties of isocyanate. Rest of the lesson in PPT.
Alkyl isocyanide, commonly it is known as in IUPAC carbylamine. The carbylamine suffix will be added in IUPAC. See the first one, CH3NC. CH3 means methyl, NC means isocyanate. So in common name, CH3NC means methyl isocyanate. But in IUPAC, CH3 is a methyl. In NC also one carbon is there. So for that only we are writing suffix as a carbylamine. Then N is a amine. The next one, CH3CH2NC. CH3CH2 is a ethyl, and NC is a isocyanate in common name. And IUPAC name CH3CH2 as a ethyl, and NC is carbylamine. And third one, there is 3 carbon, so propyl isocyanate is a common name, propyl carbylamine is a IUPAC name. And C6H5NC, C6H5 is a phenyl, and that NC is a isocyanate in common name, but in IUPAC name NCS we called as carbylamine. So in IUPAC name phenyl carbylamine is the name of C6H5NC. Preparation of isocyanate. From the first one, primary amine, it is important reaction, carbylamine reaction. See the first example, methylamine, it is reacted with the chloroform, CHCl3 is a chloroform, and potassium hydroxide. The chloroform is treated as carbon, hydrogen and 3 chlorine, and potassium hydroxide 3K and 3 OH. First of all, the CH3N, it is attached with C, so we get CH3NC methyl isocyanate, and 2 hydrogen from methylamine and 1 hydrogen from chloroform. It is combined with 3 OH, we get 3 moles of water, and 3 chlorine from the chloroform, and 3 potassium from the potassium hydroxide. Combined with each other we get 3 potassium chloride. The same way in alanine also, the same way they attach and then give the product phenyl isocyanate, 3 potassium chloride and 3 moles of water. From alkyl halide, the first see the example, ethyl bromide is reacted with the ethanolic solution of silver cyanide. On heating, the AG is combined with the Br of ethyl bromide, and then instead of Br the Cn is attachment, we get ethyl cyanide. But when that cyanide nitrogen is attached instead of carbon, then we get ethyl isocyanate. So we are getting 2 product here, but which one is major means ethyl isocyanate is a major product and ethyl cyanide is a minor product. Third preparation from N-alkyl formamide. For that here it is given N-methyl formamide. Then the nitrogen is attached with CH3, that is called as N-methyl. The remaining thing is called as formamide. Then the N-methyl formamide is reacted in presence of phosphorus oxide trichloride and pyridine. I indicated blue color, 2 hydrogen and 1 oxygen is removed as water. Remaining thing if we write means we get methyl isocyanide, or IUPAC name is methyl carbylamine. Next, physical properties. In physical properties, isocyanide are colorless and highly unpleasant smelling volatile liquids, and they are, when compared to the cyanide, they are more poisonous. And also, then third one, you see that less polar than alkyl cyanide. These are the difference between the isocyanide and cyanide. The same way, another one, the melting point and boiling point, that is also lower than the cyanide. So there is three different from the cyanide. First one is more poisonous, then second one is they are less polar, and then melting and boiling point also lower than cyanide. In second point, they are slightly soluble in water. But which are slightly soluble in water, they are highly soluble in organic solvent. Why they are slightly soluble means they are organic compound. Chemical properties of alkyl isocyanide. There are two types of hydrolysis. One is base hydrolysis by using alkalis. Another one is acid hydrolysis. But here the alkyl isocyanate, they are not hydrolysis by alkali, but they are hydrolysis with the help of acid. Here we are going to see the acid hydrolysis. So acid is indicated in arrow mark, and the methyl isocyanate, 2 moles of water are added. I split the water as a 2H, 2H, 2O. The 2H goes to nitrogen, and remaining 1 carbon in isocyanate and 2 hydrogen, 2 oxygen in water combined with each other, it gives formic acid. So in hydrolysis we get the amine, primary amine, and also acid. The next one, reduction. Reduction means addition of hydrogen. So for reduction we are going to use the reducing agent, sodium bar, ethyl alcohol, or nickel. So in this reducing agent gives the Nussen hydrogen. Here 4 Nussen hydrogen is there. I split into hydrogen and 3H, 1H and another one 3H. The 1H goes to nitrogen, nearer to nitrogen, and 3H goes to nearer to carbon of NC. So that we get dimethylamine. This dimethylamine is a secondary amine. So on reduction of isocyanate we get secondary amine. It is an important one word goes. Next one, isomerization. Then methyl isocyanate on heating 250 degrees Celsius, that nitrogen and carbon that interchanger and then give the methyl cyanide, which is more stable form of cyanide. When compared to the isocyanate and cyanide, which one is more stable means cyanide is a more stable one. Addition reaction. When the isocyanate is added with the halogens, it gives alkyl isocyanohalide. Just the halogens are added with the carbon, we get the halide. The next one, when the alkyl isocyanate is added with the sulfur just added with the carbon, so that we get alkyl isothiocyanate. And then another third one, if the oxygen is added in the presence of mercuric oxide, we get the alkyl isocyanate, not nide, cyanide, nate. And then mercurous oxide is the one of the product. Uses of nitroalkane. The first nitroalkane is nitromethane. It is used as a fuel for cars. And chloropicrine we get from the nitromethane. When the nitromethane is reacted with the chlorine in the presence of sodium hydroxide, we get chloropicrine, that is CCl3NO2. It is used as a insecticide. Please refer the reaction in page number 203. And third one, nitroethane. Another compound in nitroalkane is nitroethane. It is the addition compound in fuel, and also it is a precursor. Before the explosive preparation, we need one compound. That compound is a nitroethane. So it is a precursor to explosive, and also it is a good solvent for polymer, cellulose, ester, synthetic rubber and dyes. And ethyl nitrate. Ethyl nitrate is the tautomer of nitroethane. That ethyl nitrate 4% solution in alcohol. It is known as sweet sprit of nitrate, and it is used as a diuretic. Nitrobenzene. That nitrobenzene is used to produce lubricating oil in motor and machinery, and it is used to manufacture dyes, drugs, pesticide, synthetic rubber, aniline, and explosive like TNT. TNT means trinitrotoluene. TNB means trinitrobenzene. Uses of cyanide and isocyanide. The alkyl cyanides are intermediate and used to produce large number of organic compounds like acid, amide, ester and amine, etc. And nitrile. Nitrile means nothing but cyanide. IUPAC name is nitrile. They are used in textile industry to produce nitrile rubber and used as a solvent, so that they are used in perfumery industry. Next, they used as a cancer drug, the mitomycin C. It is a anti-cancer agent. It contains aziridine ring that used in the stomach and colon cancer. And this aziridine functional group participate in the drug degradation by DNA, so that the cancer cells put into death.